United States fifth-generation fighters have dominated the skies with their advanced capabilities. They have been unrivaled and undefeatable, taking charge as the world's most sophisticated fighters. However, a more cutting-edge fighter jet from Russia has challenged this claim, proving that the U.S. fifth generation is now unbeatable after all. This Russian fighter possesses advanced capabilities and lethal features that have shocked the United States Air Force. Is this Russian fighter formidable enough to take on one of the most advanced aircraft in the world? What are the capabilities of this fighter? Join us as we explore the designs and capabilities of the only fighter jet that can beat the F-35. On June 8th, Russia took a significant blow when Ukrainian forces hit a Su-57 fighter jet at Akbank Air Base, about 366 miles from the front line. This was the first time a fifth-generation fighter jet was destroyed in combat, which is especially surprising considering that the Su-57's main competitor, the F-35 Lightning II, has over 1,000 units built. The Su-57, known by NATO as the Felon, is a single-seat, twin-engine fighter designed for multiple roles. It's one of only 4 fifth-generation fighters in the world, alongside China's J-20 and the American F-22 and F-35, the latter being the Su-57's closest rival. Let's explore the designs and capabilities of the Su-57. Su-57 Felon is built for air superiority, excelling in aerial combat as well as ground and maritime strikes. It's equipped to be one of the most advanced fighters in the world, but it faces tough competition from the F-35 Lightning II. It is a fifth-generation fighter jet, known for being Russia's first stealth aircraft in active service. It's designed to be versatile, capable of handling various missions, and focuses on stealth and high maneuverability in all directions. The plane also features large internal bays for carrying weapons and advanced sensors, including a radar system that allows for a high degree of automation. Sukhoi, the company behind the Su-57, looked at the F-22 Raptor as a model for creating a highly maneuverable stealth fighter. However, they aimed to fix some issues they saw in the F-22, such as its limited ability to use thrust vectoring to change direction and its small space for carrying weapons. They also felt the F-22 wasn't suitable for the multi-role missions needed by Russia, as it focused too much on air-to-air combat with fewer weapons. The aircraft has a wide, blended body with 2 engines placed far apart and includes movable horizontal and vertical stabilizers, with the vertical ones tilted for better stealth. The wings are shaped like a trapezoid and include flaps and other control surfaces to help with maneuverability. The plane also uses thrust vectoring to improve its agility and has special extensions on the wings to improve control at high angles and recover from stalls quickly if the thrust vectoring system fails. For braking in the air, the plane's ailerons move up while other control surfaces move down, and the vertical stabilizers turn inward to create more drag. The Su-57 is made from a combination of materials, with about 40% being aluminum and 18% titanium, but it also uses a lot of composite materials, making up about 75% of its outer surface and 22 to 26% of its structural weight. The Su-57 was designed to handle multiple roles. Unlike the F-35, it has a large internal space to carry various air-to-surface weapons. These weapons are stored in 2 main bays located between the engines, along with smaller side bays near the wings. Keeping the weapons inside the aircraft reduces drag, which improves performance and helps maintain its stealth features. It is highly maneuverable and stable in flight, thanks to its advanced flight control system and thrust vectoring nozzles that can direct the engine's thrust. This allows the jet to perform complex maneuvers like the Pugachev's Cobra and the Bell maneuver, as well as flat rotations without losing much altitude. The aircraft's design and powerful engines enable it to reach speeds of Mach 2 and fly at supersonic speeds without using afterburners at Mach 1.3. This gives it a significant advantage in range and speed over older aircraft models. The Su-57 can fly over 1,500 kilometers at supersonic speeds, which is more than twice the range of the Su-27. It also has an extendable refueling probe to further increase its range. While the F-35 is a single-engine aircraft, the Su-57 packs 2 powerful fire spitters in its rear. On the F-35 is the Pratt & Whitney F-135 low-bypass augmented turbofan that provides 43,000 pound force of thrust with afterburner, thrusting the jet to a top speed of Mach 1.6 to 20 slower than the Mach 2 top speed of the super cruise-capable Su-57 with afterburner engaged, thanks to a pair of NPO Lilka Southern Isdeli 117 engines that produce a combined thrust of over 63,000 pound force. But what the F-35 lacks in thrust, it seems to make up for in engine stealth. The engine on the F-35 has a low observable afterburner that incorporates fuel injectors into thick curved vanes. These vanes are covered by ceramic radar-absorbent materials and mask the turbine. Its low observable axis-symmetric nozzle consists of 15 partially overlapping flaps that create a sawtooth pattern at the trailing edge, which reduces radar signature and creates shed vortices that reduce the infrared signature of the exhaust plume. The F-135 PW600 engine for the F-35B, a variant of the F-35 designed for the U.S. Marines, supports short takeoff and vertical landing by incorporating a shaft-driven lift fan. This SDLF was designed by Lockheed Martin and developed by Rolls-Royce as a key technology for the F-35, displaying the most impressive use case and performance. So much so that the system was awarded the prestigious Collier Trophy in 2001. The Su-57 is the first Russian military aircraft designed with a focus on stealth. To reduce its radar visibility, it uses several techniques similar to other stealth fighters like the F-22. The edges of the wings, control surfaces, and panels are carefully aligned and angled to minimize radar reflections. Weapons are stored inside the aircraft, and antennas are recessed to keep the stealthy shape intact. The aircraft is also coated with radar-absorbent material, or RAME, to absorb radar signals and reduce the chances of detection. The entire fifth-generation class of aircraft is heavily dependent on stealth capabilities, so neither the F-35 nor the Su-57 is found lacking here. The American fighter was designed from the ground up with stealth in mind. Its manufacturer, Lockheed Martin, aligned its edges, serrated its skin panels, and masked the engine with easy-to-maintain fiber matte skin for low observability. They also reduced infrared and visual signatures, enabled the reflection of radar waves, and used strict controls of radio frequency emitters. The result is a radar cross-section lower than that of a metal golf ball. However, like other stealth aircraft, the Su-57's low observability is most effective against high-frequency radars, which are typically used by other aircraft. Low-frequency radars, such as those used for weather and early warning, are more likely to detect the Su-57 because of its size, but these radars are larger, more prone to interference, and less precise. To preserve their stealth profiles, both fighters by default carry their weapons internally, although they both have external hardpoints to carry weapons when stealth isn't the topmost priority. The F-35 has 4 internal hardpoints and 6 external hardpoints that combine to hold up to 18,000 pounds of weapons. These weapons are a combination of the most advanced American air-to-air missiles, air-to-surface missiles, and anti-ship missiles. It also wields conventional bombs such as the GBU-53/B Stormbreaker and nuclear bombs such as the B-61 Mod 12 nuclear bomb. For more rapid fire, the F-35 packs a 180-round, 25mm GAU-22/A4 barrel rotary cannon that fires 3,300 rounds per minute, which is far superior to the 1,500 rounds per minute of the 30mm Ryazov Shipunov JISH-31 autocannon on the Su-57. There's a reason for this. The F-35, being a multi-role fighter, would be tasked with providing close air support to troops on the ground in a bid to replace the renowned A-10 Warthog. The Russian fighter has 6 internal hardpoints and 6 external hardpoints that combine to carry an estimated 16,500 pounds of weapons, slightly less than the weapons payload of the F-35. On its hardpoints is a combination of air-to-air missiles, air-to-surface missiles, anti-ship missiles, anti-radiation missiles, and conventional bombs. It's unclear if the Su-57 would be able to wield nuclear weapons like the F-35 can. The Su-57 takes things further with thrust vector control. The engine nozzles can rotate to direct thrust in different directions, allowing the jet to execute complex maneuvers in pitch, yaw, and roll. This level of control, first seen in earlier Sukhoi models like the Su-30 MKI and Su-35S, makes the Su-57 incredibly agile, capable of feats that seem to defy the laws of physics. The engines also include variable intake ramps for efficiency at supersonic speeds, and retractable screens to protect against debris when taking off from rough runways. However, the AL-41F1 engines haven't been without controversy. In 2011, a Su-57 had to abort takeoff due to a compressor stall during the Moscow Air Show, raising concerns about reliability. Looking to the future, the Su-57M is set to receive an even more advanced engine, the AL-51F1, by the mid-2020s. This new engine, designated as ISDELI 30 during development, will provide even more thrust, which is up to 37,500 pounds in afterburner, while also being more reliable and stealthier, thanks to innovations like glass fiber plastic components and a new nozzle design with serrated flaps. As if that weren't enough, by 2023, reports surfaced that UEC Saturn is working on a sixth-generation engine design for the Su-57, pushing the boundaries of what this fighter jet can achieve. By December 2023, all new Su-57s delivered to the Russian Air Force will be equipped with this advanced Stage 2 engine, setting a new standard for power and performance in military aviation. The Su-57 is equipped with two main internal weapon bays, each about 14.4 feet long and 3 feet wide, and two smaller side weapon bays near the wing roots. The main bays are fitted with launchers that can handle different types of missiles. The UVK-U-50L launcher for missiles up to 660 pounds, and the UVK-U-50U for those up to 1,500 pounds. The side bays use VPU-50 launch rails. For air combat, the Su-57 can carry 4 long-range missiles in the main bays and 2 short-range missiles in the side bays. The primary medium-range missile is the R-77M, an advanced version of the R-77 with improved radar guidance and a dual-pulse motor. For close-range combat, it uses the R-74M2, a heat-seeking missile designed to fit inside the aircraft. There's also a new short-range missile, the KAMD, in development to eventually replace the R-74M2. For longer-range missions, the Su-57 can carry the ISDELI 810 missile, an upgraded version of the R-37M. For striking ground and sea targets, the Su-57 can carry precision-guided bombs like the KV-250 and KV-500, as well as a variety of missiles including the KTH-38 for air-to-ground attacks, the KH-35U anti-ship missile, the KH-58 USHK anti-radiation missile, and the KH-69 cruise missile. When stealth is not a priority, the aircraft can also carry weapons on 6 external hardpoints. Additionally, a new hypersonic missile similar to the KH-47M2 Kinzhal is being developed for internal carriage within the Su-57. The Su-57 also features a 30mm autocannon mounted inside the aircraft near the right wing root. This cannon has an effective range of about 870 yards against aerial targets and 2,000 yards against ground targets. One main feature of the aircraft is a modern glass cockpit without any old-style analog gauges. Instead, it displays information on 2 large 15-inch multifunctional LCD screens, similar to the setup in the Su-35S. Additionally, there is a smaller multifunctional display and a digital control panel. The cockpit includes a wide-angle head-up display that gives the pilot key information directly in their line of sight. The primary controls are a joystick and a pair of throttles, with major functions managed through a hands-on throttle and stick system. The aircraft's canopy is made of 2 parts, with the rear section sliding forward to lock into place. This canopy is coated with a special material to reduce the plane's radar visibility. For pilot safety and comfort, the Su-57 uses the NPP Zvezda K-Kuya with 36D5 ejection seat and the SOG-50 life support system, which includes anti-G protection and an oxygen generation system. The pilot wears a Zeiss AH-10B helmet equipped with a digital display that tracks eye movements, helping to target enemies even at high angles. The oxygen system provides an unlimited supply during flight. The life support system allows the pilot to perform intense 9G maneuvers for up to 30 seconds. The ejection seat, along with the PPK-7 flight suit, ensures safe ejection at altitudes ranging from ground level to 66,000 feet and speeds up to 810 miles per hour. The system also includes a survival kit to help the pilot after ejection. Both the F-35 Lightning II and the Su-57 are fitted with the most advanced avionics and armament their respective countries have to offer. For the F-35, the AN/APG-81 Active Electronically Scanned Array Radar, AN/ASQ-239 Barracuda Electronic Warfare System, AN/AAQ-37 Distributed Aperture System, AN/AAQ-40 Electro-Optical Targeting System, and AN/ANQ-242 Communications, Navigation, and Identification Suite, all combine to provide rapid beam agility, multiple operational modes, all-aspect missile launch and target tracking, 10 radio frequency antennas, all-aspect radar warning receiver, self-defense against missiles, the detection and jamming of hostile radars, laser targeting, forward-looking infrared capabilities, long-range IRS functions, and an impossible level of sensor fusion to give the pilot and friendlies an omnipresent tactical picture of the battle space without compromising stealth. All of these are made possible by software running on a shocking 86 million lines of code, which is more than double the 4 million lines of the Su-57's code. But this isn't a coding competition. And in terms of avionics, the Su-57 has its own statement to make. Its central integrated management system fuses all the data from the SH-121 radar and electronic warfare radio electronic system, the 101KS electro-optical system, multiple, the NO-36 radar DAR-101, X-band, active electronically scanned array radar, and 2 the NO-36 radar L-band transceivers for friend or foe identification and electronic warfare. This allows for the total integration of avionics systems, maximization of pilots' situational awareness, and reduced workload. Still, the priority for the Su-57 is air superiority, and thus it has fewer avionics systems than the multi-role F-35. Unlike the F-35, the Russian fighter has the PAK-FA program. One of the main technical goals of the PAK-FA program is to fully integrate the Su-57's avionics systems, or sensor fusion, to improve the pilot's awareness of the surroundings and reduce their workload. The integration of these systems is managed by an information management system developed by GRPZ from Ryzen. The key systems include the SH-121 Multifunctional Integrated Radio Electronic System and the 101KS Atoll Electro-Optical System. Unlike earlier Sukhoi aircraft, Sukhoi itself handled the integration of the IUS, rather than relying on RPKB over Menskia. The Integrated Avionics Suite, known as IMABK, uses fiber optic channels and runs on over 4 million lines of code. The SH-121 system includes the NO-36 Bielka radar system and the L-402 Himalayas electronic countermeasure system. The NO-36 radar, developed by Tikhomarov NI Institute, features a main nose-mounted X-band radar with 1,114 modules and 2 side-looking X-band radars with 404 modules each, providing wider coverage. The radar antennas are tilted back for stealth purposes. The side radars allow the Su-57 to guide its own missiles while performing evasive maneuvers. The system also has L-band transceivers on the wing edges, which help with identifying friend or foe in electronic warfare. The L-402 Himalayas ECM suite works with both its own arrays and the NO-36 radar system, with one array located between the engines. Communication and data exchange between aircraft and command centers are managed by the S-111 system. The 101KS Atoll Electro-Optical System includes various sensors like the 101KSV Infrared Search and Track, 101KSO Directional Infrared Countermeasures, and others for navigation and targeting. The URST is mounted near the cockpit and can track multiple targets, while the DURCM system, a first for a fighter aircraft, has turrets mounted on the aircraft to protect against incoming missiles. The Su-57 can also deploy countermeasures like flares and radar decoys from dispensers in the tailboom. For navigation, the Su-57 uses the BINS SP2M inertial navigation system, which can work with GLONASS and is controlled by the IVS-50 computing system. KRET, the developer, announced in 2016 that it is working on a video processing system called Okotnik to improve target detection and tracking. The aircraft also has a monitoring system that can predict the lifespan of its composite parts, making maintenance more efficient. Additionally, the Su-57 could be used to test advanced AI and unmanned teaming technologies for future fighter programs. and it has even demonstrated autonomous flight without pilot input. It is important to note that over 1,000 F-35s have been built since 2006. While Russia struggles to build a Su-57 in any significant numbers, only 32 units of the fighter have been built since 2009, many of which can't currently take to the skies to protect their nation. And the ones that can are apparently being picked off and destroyed in the Ukraine war. The war has also reportedly slowed down the already slow production of the Russian fighter. So in a battle between the F-35 and Su-57, it'll be a case of entire colonies of hundreds of F-35s up against 24 Su-57s. It would be an unfair fight, and regardless of their capabilities, the winner can be seen before a single shot is fired. Thanks for watching. While you are still here, click on the link appearing on your screen to check out another of our videos. See you there!